evaluating and assessing the quality of an exam that consists of multiple choice questions by performing item analysis. Four major components form part of the item analysis. The first one is the reliability test. The second one is the item discrimination analysis. The third one is the item difficulty analysis. And the fourth one is the item distractor analysis. In this presentation, I'm going to describe the background and give an example for each component of the item analysis. And the first one is the reliability test. And I will describe three different approaches to calculate and determine the reliability of an exam and generate a value based on these three different approaches: the Cooder-Richardson 20 formula, the Cooder-Richardson 21 formula, until explain the difference between both and when to use the first one and when to use the second one. And the third approach is the Cronbach's alpha equation. And as an example and a data will be used to perform the analysis for the multiple choice exam, and the reliability test will be explained and a value will be generated. The second component of the analysis is the item discrimination, to determine which question within the exam or questions are bad and which are good, which questions can discriminate between high performing students and low performing students. Two different approaches will be explained. The first one is a mathematical method called Kelly's equation. The second one is statistical approach, which is called the point-biserial correlation coefficient. The third component of the item analysis is item difficulty, abbreviated as p-value, for determining how easy or how difficult is the question. And the way to determine the value for the item difficulty is to use the proportion calculation. And an example will be given and a value will be generated. The fourth component of the item analysis is the item distractor. A distractor is the incorrect answer options within a multiple choice question. And the distractor function is to distract the student from selecting the correct answer and attract them to select the wrong answer. The analysis will be described, and two methods will be explained on how to generate a value for item distractor. The first one is the percentage value. The second one is the item discrimination. So the item analysis is an important analysis for the development of an exam questions. It does look at the questions and the overall of the exam. It does examine each item or each question to assess the quality of those items and the test or the exam as a whole. It is trivial in improving the items to be used repeatedly in further tests. So each question will be examined and assessed, and whether it is good or bad, whether it needs improving, to be used in subsequent further tests or exam. It is a statistical and mathematical methods, this item analysis, that are used to determine the quality of multiple choice question exam. It examines each individual question to identify items that are badly phrased and should be changed or replaced. So the item analysis reveals the overall reliability of the exam, whether an item is failing to discriminate between excellent and poor students, whether an item is too easy or too difficult, and whether the distractor is functional and effective in distracting the student from selecting the correct answer or answer options. The most common item analysis tests are the reliability test that measures the extent and to what extent the test is likely to produce a consistent scores if it is repeated at different dates and different times. The item discrimination will measure how well the item is discriminating between high-performing and low-performing students. The third test is the item difficulty, which will measure the proportion of the student who answered the item correctly. So it measures whether the question is easy or difficult. And finally, the last component, which is distractor analysis. This will measure how well each of the incorrect option or incorrect answer options distract the student from selecting the correct answer option. Evaluating the quality of multiple choice question by performing item analysis. One component of the item analysis is the reliability test based on Cooder-Richardson Formula 20, KR20. Reliability test measures the consistency of exam scores. It does measure how consistent, i.e. similar, student exam scores are from one exam to another if the same exam questions are used. Student scores would remain consistent over time if the same test was repeated by the same student, i.e. the exam is reliable. However, if the student exam scores were different, the exam would be less reliable. Cooder-Richardson Formula 20, abbreviated as KR20, is one of the best estimate of reliability for exam scores, exams that have only multiple choice questions. The KR20 calculates the reliability of multiple choice question exam. It does check the internal consistency of items or questions that are dichotomous, i.e. it has only two options, either right or wrong. So the data are dichotomous data or binary data. So the data are binary variable or dichotomous variable. A correct question score equal to 1 and an incorrect question score is recorded as 0. So in this case, the multiple choice question have only two possible answer, right or wrong. So 0 or 1. So this is a dichotomous data. KR20 values range from 0 to 1. A test showing KR20 value equal to 0.9 or greater have excellent reliability. On the other hand, a KR20 value of less than 0.5 5 is considered to have low reliability, or the exam is having less reliability. So Cooder-Richardson Formula 20 is published by Cooder-Richardson, and the KR20 is equal to K divided by K minus 1 multiplied by 1 minus the division of the summation of P multiplied by Q divided by the variance. K stands for the total number of questions. P stands for proportion of people who answered the question correctly. Q, proportion of people who did not answer the question correctly, and the variance of the total score for all people or students participating in the test. Now, there are several factors that affect the KR20 value. The first one is the difficulty of the test. The second one is the total number of questions on the test. The third one is the number of questions that did not discriminate or negatively discriminated. And finally, the spread in the student scores. In the table below, the range for KR20 value and the corresponding reliability label is described. So if the KR20 value is equal to 0.9 or greater, then the exam or the test have an excellent reliability. The reliability of an exam is good when the KR20 value is between 0.8 and 0.89. A KR20 value of 0.7 to 0.79 is considered to be acceptable reliability of an exam. A test that is questionable in reliability when the value ranges from 0.6 to 0.69. A value of 0.5 to 0.59 is considered as to be a poor reliability. And an exam or a test that have a KR20 value of less than 0.5 is considered as an unreliable or an unacceptable exam. In the next slide, a table and the equation for a reliability test based on KR20. The table contains data for 10 students answered a multiple choice question exam that contains 15 multiple choice questions, and the score for each question for each student was inserted as either 0 or 1. 0 for incorrect answer and 1 for correct answer. And to evaluate the quality of the test, reliability test can be performed based on the KR20 equation. And to do that is first of all to calculate the total score achieved by each individual student by adding all the correct answers achieved by student, combining them together to generate the total score for each student. And from the total score, a variance can be calculated, and it was found to be equal to 22.36, and that variance represents the lower part of the equation. And to calculate the upper part, first of all, to calculate the p-value i.e. the proportion of the student who answered the question or the item correctly. For question number 1, 3 students answered the question correctly, so the proportion is 0.3. And for question number 15, 5 students answered the item correctly, so the proportion is 0.5. Once the p-value is calculated, then the q value will be calculated. Q represent the proportion of the student who answered the question incorrectly, and to obtain the value for the q is to subtract the p-value for the item from 1. So 1 minus 0.3 equal to 0.7 for question number 1. Once the p-value and the q value for each individual item is calculated, the p multiplied by q value will be calculated also. And the way to do that is to multiply the value for p by q, and then to add all the value for the multiplication of each individual questions, multiplication of p by q, to add up all the value to generate the sum of p multiplied by q, which equals to 3.42. Now, most of the values are ready now to be replaced and used and inserted into the equation. As shown here, k represents the number of the questions or items, and in this case k equal to 15. So if we replace the value or the values in the equation, we find out that KR20 equal to 15 divided by 15 minus 1 multiplied by 1 minus the upper part, which represent the sum of p multiplied by q, divided by the variance of the total score. And the value for KR20 generated is equal to 0.91, which means that the exam or the test is 91% reliable. Evaluating the reliability of multiple choice question exam by performing reliability test. Reliability test is one of the item analysis component, and one way to do the test is to use the Coder-Richardson Formula 21, KR21. Coder-Richardson Formula 21 is different from the Coder-Richardson Formula 20. However, the formula calculates the reliability of binary test. Binary means that it's dichotomous, only have two options, such as multiple choice questions in which the answer can be either correct or incorrect. Correct will be given a value of 1, and incorrect answer will be given a value of 0. So the KR21 measures the consistency of exam scores. The formula assesses the inter-item consistency, and the Coder-Richardson Formula 21 is used instead of the KR20 when the questions in a test all have approximately the same difficulty, i.e. the mean score of each question is approximately equal to the mean score of all the questions. The KR 21 values range from 0 to 1. 0 mean unreliable exam or test. A value of 1 means that it's extremely or it is an excellent reliability of a test or an exam. Coder-Richardson formula 21 is described here, equal to k divided by k minus 1 multiplied by 1 minus the division of mean multiplied by the k minus the mean divided by the k multiplied by the variance. The k here stands for the total number of questions. The variance is the variance of the total score, and the mean is for the mean of the population. The following table shows the KR21 value and the reliability level. If an exam has a value of KR21 of 0.9 or greater, then the test will have an excellent reliability. A KR21 value between 0.8 and 0.89 is considered as a good reliability. A test that will have an acceptable reliability when the value for KR21 is between 0.7 and 0.79, and that a questionable reliability of a test when the value ranges between 0.6 and 0.69. A test will have poor reliability when the value is between 0.5 and 0.59, and a multiple choice question, exam or test will have an unacceptable reliability or is unreliable when the value for the KR21 is less than 0.5. Reliability tests using the Cronbach's alpha equation is one of the analyses and form part of the item analysis to evaluate the quality of multiple choice question exam by investigating and assessing the internal consistency of an items within a test. Cronbach's alpha, or equivalently called alpha coefficient, was developed by Lee Cronbach in 1951. It refers to how closely related a set of items of an exam. It does assess the reliability of exam items. It measures internal consistency of items in a test that are dichotomous, i.e., correct or incorrect, such as multiple choice questions. Alpha measures the interrelatedness of the items within the test, and the alpha coefficient of reliability ranges from 0 to 1. If all the items are not related, then alpha will be equal to 0, and if all of the items co-vary, i.e. related, then alpha is close to 1. Cronbach's alpha increases as the intercorrelation among test item increases. A test with Cronbach's alpha score of 0.9 or greater have an excellent reliability, and a test with an alpha value less than 0.5 will have low reliability. Cronbach's alpha formula was established based on the KR20 formula, and it can be used to analyze scaled responses such as Likert scaled items or questions. It can be used for continuous variables, and it can be used to analyze the reliability of binary variables such as multiple choice questions. Cronbach's alpha formula or equation is equal alpha is equal to k divided by k minus 1 multiplied by 1 minus the summation of the variances for each individual items divided by the variance for the total score. So k represent the total number of items, the variance I represent the variance associated with each item, and the variance T represent the variance associated with the total scores. In the following table, the Cronbach's alpha range is represented by reliability level. A test that is reliable and have an excellent reliability will have a Cronbach's alpha range between 0.9 and above. A Cronbach's alpha range of 0.8 to 0.89 will have a good reliability. A test with an alpha range of 0.7 to 0.79 will have an acceptable reliability, and a questionable reliability of a test will have a range of alpha between 0.6 and 0.669, and an alpha range between 0.5 and 0.59 will have a poor reliability. An exam or a test that has a Cronbach's alpha less than 0.5 will be or will have an acceptable reliability and will be unreliable test or exam. In the next slide, a table and a Cronbach's alpha equation. The table represents exam results for 10 students who had answered 15 multiple choice questions. A correct answer for each question is recorded as 1, and incorrect answer is recorded as 0. And to evaluate this exam and assess the multiple choice question and determine whether the exam is reliable or not, we will use the Cronbach's alpha equation. And the first step is to do and calculate the total score achieved by all the students participating in the exam. And the total score is calculated by adding all the correct answer or answers each student had scored. Once the total score for each individual student is calculated, a variance for the total score is calculated as given here, which is equal to 22.36. The next step is to calculate the variance for each individual item or question, as shown here in this blue shaded row. Each question has its own variance, and then from the variance for those questions, the summation or the sum of all the variance are calculated or determined by adding all these variance. So the total score variance has been determined, and the summation of the variance for all the items is calculated. Then the equation can be used to determine the value for Cronbach's alpha. And for the equation as shown here, k is equal to 15, as we have 15 multiple choice questions, and the summation of the variance is equal to 3.42, and the variance for the total score is calculated. Then using the equation here and placing and inserting the value for each letters in the equation and symbol by using the k divided by k minus 1 multiplied by 1 minus the summation of variance for items and the variance for divided by the variance for the total score. So if we replace the value of 15 divided by 14 multiplied by 1 minus the value for the upper part and the value for the lower part, to generate a value of 0.91, which represent the reliability of the exam. So this exam or test is 91% reliable. Item discrimination ID is one component of the item analysis of multiple choice question exam. The ID analysis can be used to evaluate the quality of items or questions in an exam. And one way to do item discrimination analysis is to use the equation proposed by Kelly. Item discrimination, abbreviated ID, is a method proposed by Kelly in 1939. It is a measure of whether an item, which is a question in this case, distinguishes between students who learned the subject content well and students who did not. The measure is based on the comparison of performance between excellent and poor students in the exam as a whole. The item discrimination is calculated by arranging the student total score from the test in a descending order. Group the students based on their scores into upper group and lower group. The upper group contains the top 27% of overall scores, and the lower group includes the lowest 27% of overall scores. Count the number of the correct items in the upper group, and then count the number of the correct items in the lower group. Then subtract the correct questions in the bottom group from the correct questions in the top group. Then use the Kelly's formula to calculate the item discrimination as given here. The ID equal to upper group minus lower group divided by 27% of total students, i.e. calculating the upper group proportion and the lower group proportion and subtracting them to get the ID. An ID percentage also can be calculated by multiplying the ID product with 100. Now, the item discrimination values range from -1 to +1 based on the equation of Killy's. The outcome of the calculation have a range of -1 to +1. Positive value of +1 indicates that the item is discriminating between high performer and low performers, and +1 indicates a perfectly discriminating item. Zero value means that the item is not discriminating between high performers and low performers. On the other hand, negative value of -1 means that the item discriminates perfectly, except that low performing students answering item correctly and high performing student answering it wrongly. As shown here in the table, the range for the ID value is listed, and the items are classified as either bad item when the ID value is from 0 to 0.24, that is based on Killy's formula. Good item when the value is between 0.25 to 0.39. Excellent item when the value is between 0.4 and 1. If the ID value is minus, then the item is very bad and it is recommended to remove and exclude the item from the exam or the test. In the next slide, on the left hand side, a table for a data extracted from an exam that contains 10 multiple choice questions, and the questions were answered by 20 students, and each correct answer for each multiple choice question, the value for correct answer is inserted as 1, and the value for incorrect answer or wrong answer is placed as 0. And to determine whether these questions are good or bad, whether they can discriminate between high performing student and low performing student, item discrimination analysis can be performed. And the first step in the analysis is to calculate the total score achieved by each individual participant or student, i.e. for student number 1, count all the correct answer as given in the column on the right hand side, which shows the total score. So using the item discrimination equation given here below, the next step is to rank this total score achieved by each individual student from high to low in a descending order as shown here in this slide. Once this order is performed, the next step is to divide the students into upper group and lower group. The upper group will represent the top 27% of the total score of the student that had achieved highly, and the lower group will represent the lowest 27% of the student who scored lowest score. So in this case we have 20 students, and to 27% out of 20 is nearly equal to 6. So we're going to select six students from the who have high scores and 6 students from the who have lowest score. using the equation given below here, and as it's shown in the rows showing the upper group will have the first six the scores for the first six students who had scored highly. So we count the number of the correct score for the first question, and it's found to be 2. And this is the same for question number 2, 3, 4 up to number 10, as shown by question number 10, that 6 students answered the question correctly. And at the same time also calculate the lower group by counting the number of the student who had scored correctly for this question. For question number 1, no one has scored, so it's 0. For question number 2, 6 students had answered the question correctly, and for question number 10, only 3 students had answered the question correctly. Once the upper group and the lower group are calculated and determined using the formula or the equation given here, then the item discrimination can be calculated by using the value here of upper minus then the value in the lower group for each individual item, and then divide that by 6 because we only have 6 in each group, and a value for item discrimination is generated ranging from -1 to 1, passing the 0 value. Again, we can see here one of the questions here have a 0 value for ID, one question that have a minus, also question number 6 ID value, and question number 5 have a high positive ID value. Another component of the item analysis of multiple choice question is the item discrimination that will determine whether the item or the question can discriminate between high performing students and low performing students. The analysis is based on statistical calculation using the Point-biserial correlation coefficient. Item discrimination. Item means a question or refers to a question. Item discrimination assists the exam quality, assessing each question in exam sheet as either good or bad question. It does differentiate between students who have mastered the subject content from those who have not. It does determine how well an item is discriminating between good and poor students. Point-biserial correlation coefficient assists the educator or educators to identify good or bad test questions. So the coefficient is one of the item discrimination index. It does measure the discriminating power of an item or a question. It is a method of measuring the relationship between student total exam scores, continuous variable from 0 to 100, and students' item mark or score, dichotomous variable. Dichotomous mean two categories, correct or wrong answer. It does measure the strength of the relationship between two sets of data. So here in this case we have two variables. We need to correlate two variables with each other. One of the variable is continuous, such as the total mark, which is in percentage from 0 to 100, and the other variable is categorical. Two categories, correct or wrong answer. The test, statistical test, the point-biserial correlation coefficient, does measure the direction of the relationship, and it does calculate the significance of the relationship by producing a p-value. A p-value less than 0.05 indicates significant relationship. P-value greater than 0.05 indicates non-significant association. Now, the statistical test for point-biserial correlation coefficient generates a value or values, and these values range from -1 to +1. +1 indicate a perfect correlation, positive correlation. -1 indicate a negative correlation, a strong one. Now, positive value of the coefficient indicates that the learner who answered a given question correctly also have a high score on the overall exam, and those who answered the same questions wrongly have low total mark in the test. A high positive value indicates that the question is discriminating high performing students from low performing students. Negative coefficient value means a high performing students are getting the answer wrong and low performing students are getting it right. In this case, remove the question from the exam paper. However, if the coefficient value is 0, that means the item or the question is not discriminating between students. So it's worth changing it or modifying it. In this small table, any value of point-biserial that is greater than 0.4 indicate that the question is very good, and a value of 0.25 to 0.4 suggests a good items. Fair item have a point-biserial value of 0.15 to 0.25. Any question that have a value of point-biserial of less than 0.15, then it is a bad question or a bad item that worth modifying or omitting from the exam. Here in this table shown an exam result for 15 students answering 15 questions and multiple choice questions, and each question is recorded, the score for it, as either 0 on 1, 1 is correct answer, 0 wrong answer. To perform biserial correlation coefficient statistical test to perform the statistical test to generate the coefficient or calculate the coefficient, we first have to calculate the correct answer that each individual student has achieved, and then by adding all the questions scores for each individual student together, divide them by the total number of questions, in this case 15, and then multiply them by 100 to generate the total mark or total score or the percentage of the total mark as it is given here in the blue marked values in the column labeled as mark. So for in the point-biserial correlation, once the total mark is calculated, the test is performed and the test will correlate each specific questions, the value in each questions, the scores in each questions with the total mark as shown here in this again slide. To calculate the R, which is the coefficient, or to execute the point-biserial correlation statistical test to generate the coefficient, take every question with its value and scores 0, 1 and correlate that with the total mark for the whole students. And we do this for every question or every item to generate specific R value for each question and the P value for that question. This is how it is done in a statistical package or software. In this slide, this is a scatter plot showing a correlation between wrong and correct item, an answer wrong and correct for question number 5, and as we can see here in the y-axis is labeled as exam mark from 0 to 100, and on the x-axis it is labeled from 0, 1. 0 means wrong answer, 1 means correct answer. As we can see here, most of the students that who answered question number 5, item number 5, tend to have higher overall exam mark compared to those who had answered the question number 5 wrongly, tend to have lower total score or total mark. So this question 5 from this scatter plot can be considered as really a good questions. It can discriminate between the high performing students and low performing students. The next slide shows item analysis using the point-biserial correlation coefficient either in SPSS or in another package software called Excel. As we can see here, for each individual question, there is a value calculated for point-biserial value calculated and a p-value for question number 1 to question number 15. Again, here we have questions with their point-biserial value and p-value. In the red labeled scores question number 1, we see that the value is negative and it is not significant because the p-value is greater than 0.05. Again, this question number 1 indicate that higher performing students are answering this question wrongly and low performing students are answering it correctly. So this question is a very bad question that need to be removed from the exam as it is negative. If we look at the question number 6, which is labeled yellow, we can see the value for the coefficient or the R is close to 0 and the p-value is very high. So this question is not discriminating between high and low student. So it is close to 0 and it's considered to be a bad question and it's either required to be modified or omitted from the exam. If we look at question number 11, 12 and 13, we can see that the R value is very high, 0.51 for question number 11, and the p-value is less than 0.05. So this question number 11 is a very good question in discriminating between students. So it is classed as or categorized as a very good question. Again, number Q12 also a good question, as it is the value for it 0.33 and the p-value less than 0.041. And the same thing for question number 13. It is, we can call it a very good question, as the value, R value is 0.48 and the p-value is very low. If we again go back again and look at question 2, we can see that question 2, the R value is 0.15, which is, we can call it a fair question. However, since the p-value is not significant, then this question also is not discriminating between high and low performing students and need to be remodified. Again, from this table on the bottom, we can say that question number 3 is a good question. Question number 4 is a very good question. Number 5 is a very good, if not excellent question. Number 7 is not a good question. Number 8 is a good question. Number 10 is a good question. And 11, 12, 13, I have described them. Number 14 is a very good question. Number 15 is a very good question. And number 16, I have the data for it, but it wasn't included in the tables. But again, number 16 here, it is a very good question, as the p-value is less than 0.05. So this is the way to use the power of the point-biserial correlation coefficient to determine the R value and the p-value, and to look at the correlation between specific question and correlating it to the overall mark to determine whether the question is good or bad. Describing item analysis of multiple choice question exam. An item is the question. One component of the item analysis is the item difficulty, or the p-value, proportion value, or percentage value. The item difficulty determines whether the question or the item is very easy or very difficult, based on using a mathematical calculation. Item difficulty measures the percentage of students who answered multiple choice question item correctly. It is frequently called the p-value, proportion, or percentage value. The item difficulty value range between 0 and 1. The item difficulty reveals whether an item is too easy or too hard. A higher percentage item difficulty indicates an easier item, and a lower percentage item difficulty indicates a more difficult item. Value of 1 indicates very easy question, and value of 0 points to a very hard question. An item with a p-value of 0 or 1 does not differentiate between students who know the subject and the material and the content and those who do not. In this case, if you have an item difficulty for a question that is 0 or 1, delete that item from the exam or exams that are either too easy or too hard. And an ideal question has an item difficulty value between 0.4 and 0.6. The way to calculate the item difficulty is to use the following equation. Count the number of students answering item correctly, divide that by the total number of students, then multiply the product by 100 to generate an item difficulty. The table below classify the questions according to the value of the item difficulty. An item difficulty with a value range between 0 and 20% is considered as a very difficult question. A question with 21 to 40% range is a difficult question. An item that has 41 to 60% range value is considered as a moderately difficult question. And any question that has a range of 61 to 80% considered to be an easy one, and an item or a question that has a p-value greater than 81% considered to be a very easy question. So these are the criteria to classify question based on the item difficulty value. In this table shows 15 multiple choice question answered by 10 students, and the answer was recorded as 1 for correct answer, 0 for wrong answer. And to calculate the item difficulty or the p-value for each question, add all the correct answer scored for each questions and divide that by the total number of students. For the first case, it's 5 correct answer divided by 10, so it is 0.5. And for the question number 15, 2 correct answer divided by 10 is 0.2. Again, from the p-value for each item or each question of these 15 questions, the questions can be labeled as either easy or difficult or acceptable. For the question number 1, the p-value is 0.5, so it is an ideal question within the range for moderately difficult question. The question number 2 and 3 is they both have a p-value higher value of 0.7, so that indicates that these questions are easy, and they are easy questions and need to be remodified or readjusted. Question number 4 to question number 11 are up to 11 are an idealistic questions. Question number 12 is an very easy question, as 90% of the student answered the question correctly. And for question number 15, only 2 students managed to answer the question correctly, so it is a very hard question. So this is the way to classify items or questions in an exam that contain multiple choice question, is to calculate the item difficulty. In this presentation, item analysis of multiple choice question exam will be described. One component of the item analysis is item distractor. The distractor will be defined and an example will be given, and features of the distractor will be listed. And the analysis will be performed to determine whether the distractor is effective and functional or not, using 2 separate methods. The first one is the percentage value, the p-value. The second method is the item discriminations Kelly's equation method, to determine whether the distractor can distract the student from selecting the correct answer and attracting them to select the wrong answer. Item distractors are the multiple choice answer options that are not the correct answers. This is an example of a multiple choice question. Question 1. COVID-19 infection is caused by, and there are 4 possible answer options: A, B, C, D. A is the correct answer and B and C and D are the incorrect answers. So B and C and D are called the distractors because they distract the student from selecting the correct answer, which is A, and attracting them to select the wrong answer or answers, which is B or C or D. Good item distractor should be plausible, i.e. reasonable options, but not correct. Have negative discrimination, i.e. chosen by low-performing students. Effective distractor will distract the student from the correct answer and will attract low-performing students than high-performing students. Item distractor analysis is one way to measure how well each of the incorrect option in a multiple choice question contributes to the quality of the question. It does assess whether the distractor function effectively in distracting the student from selecting the correct answer. It does examine the percentage of students who selected each incorrect answer to determine whether the distractors are functional. It does examine how good is the distractor in discriminating between high-performing and low-performing students and attracting low-performing students. 2 most frequently used indices that assess the effectiveness of a distractor are the proportion value or percentage value, as it is similar to the difficulty value, and the item discrimination that is used to determine whether the distractor can discriminate between high performing and low performing students, and the analysis is based on Kelly's equation method. So how do we calculate the distractor efficiency? Using 2 possible tests. The first one is the proportion value, in which the distractor percentage is calculated by counting the number of students selected distractor 1 divided by the total number of students multiplied by 100. The second calculation or test is the item discrimination following Kelly's method. ID equal to upper group minus lower group divided by the 27% of the students selected based on their total score. So the way to calculate the ID is to first calculate the total score achieved by each individual participant in a test or exam, then rank this total score from high to low and then group the student into upper group and lower group. Upper group represent the top 27% total scores, and the lower group represent the bottom 27% total score. So in the proportion value or test, the percentage of the students selecting the distractor is calculated, and the distractor effectiveness have a range from 0 to 100%. A distractor that has been selected by more than 5% of the students indicate that it is functional, effective distractor. And a distractor that has not been selected by any student will be non-functional, useless distractor. And a distractor that have been selected by less than 5% of the student is considered to be a non-functional distractor. Another method to assess the distractor or item distractor is to calculate the distractor discrimination. Each distractor will have its own item discrimination value. The test will compare the performance of 27% high scorer with the performance of 27% low scorers. The value ranges from 1 to -1, and the distractor have negative discrimination index value is considered to be functional, and a distractor that has a positive discrimination index value is considered a non-functional, and distractor with a 0 value of ID indicates that it is an ineffective one that needs to be replaced, rephrased, or rewritten. This is, in this slide, an example for item distractor analysis using the p-value or the percentage value. For 54 students participating in the test and answering in a multiple choice question that have 4 options, A, B, C, D. A is the correct answer, B and C and D are the wrong answers, so they are distractors. And to calculate the percentage for each, the first distractor B, 2 students selected the distractor, so 2 divided by 54 multiplied by 100 equal 4%. Distractor C has a p-value of 35%, and D has a 9% value for the p percentage or the proportion value. As we can see, the distractor B is selected by less than 5% of the students, so it is non-functional and it is useless. However, distractor C and D is selected by more than 5% of the student, thus it is functional and it is effective. Another way to analyze the item distractor is to use the item discrimination following Kelly's method. Here is an example for 100 students answering a multiple choice question that has 4 options. A is the correct answer, B and C and D are the distractors. To perform this analysis, the total scores achieved by each individual student for those 100 students is calculated, and the total score is arranged from high to low, and based on that total score, an upper group and lower group is generated. The upper group will have the top 27% total score, and the lower one will have the lowest 27%. For distractor B and C and D, as we see here, the ID value is equal to 0 for distractor B, which means that both the high performing and low performing students selected this distractor in equal proportion. Thus it is ineffective, non-functional. Distractor C, on the other hand, has been selected by the low performing student, so it attracted low performing student and it has a minus value. This distractor is functional and is effective. Distractor D is non-functional as it has attracted more of the high performing student than the low performing student to select this distractor.